So I'll give us 5 minutes. I think it's time to start this presentation. So welcome everyone to this webinar, one of hopefully many Akua webinar that we'll have in the future. This will be regarding perfect automation through abstraction. I'm Dennis Singh. I'm going to be your presenter today. And before we start, I just want to check, can everyone hear me? You can tell me or write to me or anything to verify. Great. All right, then we'll continue from there. So today we have an agenda to go through. We have the following. Let's see, there we go. So first we're going to present what is Akua, or who we are, more or less. Then we'll go into the abstraction and coding, how it is used, some use cases, some examples, how it's also used in Uipath as a RPA platform. And then we'll also go into good versus evil, which is a kind of correlation more to pros and cons of using abstraction, and then kind of consequences of using bad abstraction, or as I like to call it, being mischievous. So what is Akua? Aqua, there's a lot of terms to this. What it kind of means is another kind of automation. It's an abbreviation for it. It also does have some Hawaiian roots in its name, and it means a small tree resembling the kua tree found on Mauna Kea and in the Kona Hills in Hawaii. Here's the tree itself that we can see. Very beautiful tree, and very beautiful, of course, area. So the whole company also has, I guess, logos and colors and everything around it towards a more Hawaiian and kind of relaxed feel. So who are we? For close to a decade, we produced industry experts that have gone on to challenge conventional, lead industries, and achieve both local and on international scale. We believe in evolving for a world that is dramatically different from when we started, and our mission as an enterprise-ready learning resource is to prepare humans for the opportunities of the future. We are also RPA expertise, RPA expertise is in high demand as one of Uipath's few global office official training partners, we at Akua can offer easy-to-use materials and accessible training of the highest quality for you to become skilled in all facets of RPA. It kind of more of a selling point is, but what we can tell is that we are a dynamic team of developers and consultants with a passion for new technologies. We are an automation pure play company with focus on RPA, chatbots, and AI. We are a global Uipath official training partner. We have offices in Stockholm, Gothenburg, Munich, Frankfurt, and Chicago. We have multi-year experience of large-scale RPA projects. So about me, who am I? So I am Dennis. I'm a senior automation consultant with over 4 years of experience of RPA and over 5 years experience within IT. I have an academic background in computer science and engineering, and I worked in multiple countries around the world. And now I'm working here at Akua, and I'm presenting this webinar regarding a very fundamental concept within computer science. But before we start all of this, we kind of want to get an understanding where you all are in regards to abstraction, in regards to kind of your level of experience to that. So we have some polls and questions we kind of would like to ask. So let's see if I can start the polling. So if you can see this pop-up, please select one of the options, and it'll later be presented to you. All right, I think I'll end the polling from there. Let's see if, can I share results? Yeah, so we can see here the current level of experience when it comes to automation is varying. Everyone is in this webinar are quite normal, not normal distributed, but they are quite even in beginner, intermediate, and advanced levels. There seems to be a bit more advanced in this group, which is good. So this will hopefully be a very good learning opportunity regarding abstraction. We also have another poll. Let's see if I can share that one. Let's see. So there are two questions. Now the second one will come here. And it's just to kind of get an understanding of your knowledge of abstraction. No, wait. That's the wrong, sorry, I have to relaunch it. Polling 2, launch poll. There we go. All right, great. Let's see. I'll share the results to you too. So that we can see now is that there are people who do not know anything about abstraction. Most people know the concept of abstraction, but not how to apply it in automation. Now one that knows a lot of abstraction. So this might be a bit, I guess, of a redundant seminar or webinar, but at least hopefully I'll provide some knowledge to you who's very advanced here. And the rest of you, of course, I hope this will be a good learning for you too. So we'll stop with this now, and now we can then continue this webinar. Let's see. So from there, now we know who ACOA is, or what is ACOA, and who I am. We'll go into what is abstraction in coding. So chapter 2, abstraction in coding. First and foremost, what is abstraction? Abstraction is a fundamental concept in computer science and software development. It is a key design aspect of object-oriented programming languages and application programming interfaces. It is also one of the least understood ideas in programming, partially, I think, for semantic reasons. Abstraction is commonly defined as the extraction of relevant information from larger set of data, where utilizing abstraction allows engineers and others to simplify a code base. It is the process of removing physical, spatial, or temporal details or attributes in the study of objects or systems to focus attention on details of greater importance. The reason that this is confusing to many people is that abstraction doesn't sound like what it is, semantically speaking. It sounds like making something more vague, because that's how we use it in general language. However, in computer science, abstraction typically means simplification and separating the signals from the noise in order to make programming more efficient and effective. So how is abstraction used in structured programming? So structured programming is a programming paradigm aimed at improving the clarity, quality, and development time of a computer program by making extensive use of the structure control flows constructs of selection, such as if then else and so forth, and repetition like while loops and for loops, block structure, and of course subroutines. If you've forgotten what a programming paradigm is, then it is a way to classify programming languages based on their features. Languages can be classified into multiple paradigms, of course. So abstraction in structured programming involves the splitting of complex programming tasks into smaller pieces with clear flow control and interfaces between components, with a reduction of complexity potential for side effects. In simple programs, this aims to ensure that loops have single or obvious exit points, and where possible, to have single exit point from functions and procedures. In larger systems, it may involve breaking down complex tasks into many different modules. We can also see that this kind of structured programming falls between imperative programming and procedural programming. And then there's a lot of things we can discuss here where it kind of, or how they're defined when it comes to imperative programming and structured, or what other people say, modular programming. But let's kind of continue more into the object-oriented programming instead, which is the next slide. So in object-oriented programming, abstraction involves the facility to define objects that represent abstract actors that can perform work, report on, or change their state and communicate with each other in the system. One of these examples are classes and objects, which are more classic kind. A class is a construct which gathers data, called properties or attributes, and behaviors acting on its data, called methods. Let's take an example. We have the following code, which is PHP. You can see here the class parse used by initiating it and trying to parse a file on the last two lines. But instantiating a class, we create an object of that class. If you only look at these two lines, you don't know what happens when object is created and what the parser parse method will do. Why would you only look at the last two lines, you might ask? In real life projects, when you encounter an object and you want to see the class itself, it will be likely that you need to go into another file, into another part of your code base, and trying to understand what's happening there. If you need to do that for every object in the code you need to modify, it will get very confusing soon. In short, you hope that your parser will parse your file, but you shouldn't really care how. The class parse simplifies that operation on its data by encapsulating and hiding them. For example, the verification that the file exists is hidden when you use the object of that class. The class parse will try to generalize the concept of parsing a file. It could be used each time we need to parse a file. When it's available outside the class, the parse method is only a representation of the internal behavior of the class. The name parse describes what method is doing, but it doesn't describe the PHP function file get contents is called. For example, that's great because when you use an object parser, you don't really care. You just want to know that it can parse the file itself. But in some languages, like PHP, Java, or C#, you can create abstract classes. It's basically a template other classes can inherit from. So let's take another example of another production-ready class level file here. The abstract class hides the detail we don't care about when using it. That is the implementation of parser, for instance, verify file extension. We have now an abstract class which generalizes some validation. It can be used by any class which inherit the abstract class, like YAML parser class, for instance, which is up here. The abstract class parser represents the general idea of a parser, which could be inherited by other classes, like hypothetically an XML parser class, or even a JSON parser class. At the end, the generalization is the main purpose of an abstract class. If you need to simplify by hiding details, using a normal class is enough. Well, even if you need to generalize some concept through a bunch of classes, you can use the composition as well without any abstract classes, or even inheritance. If we continue from here, we have some more example. So there's also something called interface construct. The word interface is one of the most kind of ambiguous words we use in software development. The meaning can be very different depending on the context. That's why when I speak about language keyword interface, as you can find it in many high-level languages, I will use the term interface construct. An interface construct can hide implementation details. there's only meta signature in there, no implementation. Generalize a concept, the interface parser can be implemented by an unlimited amount of classes. And there are all two main differences between an interface construct and an abstract class. The interface construct doesn't use inheritance and allows you to follow up on other important concepts in programming, like polymorphism. And then here's, for instance, an example how it might look like. So this is an interface parser. If we continue from there, this was more examples in object-oriented programming where abstraction is used. But then there's also something called abstraction layer. So in computer science, it's commonly presents different levels or also layers of abstraction, wherein each level represents a different model of the same information and process, but with varying amounts of details. Each level uses a system of expression involving a unique set of objects and compositions that apply only to a particular domain. Each kind of relatively abstract higher level builds on a relatively concrete lower level, which tends to provide an increasingly granular representation. As an example, gates builds on electronic circuits, binary and gates, machine language on binary, programming language on machine language, applications and operating system on programming languages. Each level is embodied, but not determined by the level beneath it, making it a language of description that is somehow self-contained. And here we can go into some examples of these levels of abstraction. This is a very good example or kind of level from one of Berkeley's courses called CS61. And of course, keep in mind that this is a very rough simplification, an abstraction by itself. In reality, there are many, many more layers than this. The highest level of abstraction is the layer 1. It is the layer which is closer to the real world. The user will use it to interact with your software and do whatever he or she wants. Your high-level code using a high-level language, such as Java, will translate the business requirement you had. Again, it's pretty close to the reality, closer than the lower levels of abstraction. The high-level language can be considered as an interface to act on the other abstraction levels. Like you would use the interface of a washing machine, you don't use directly an internal mechanism, but a bunch of buttons. Abstraction in software development can use their interface to act on each other. Normally, the user should not be able to bypass the first layer, the user interface, to look at the code base, for example. The concept is known as the abstraction barrier. The layer of abstractions are normally isolated. More and more, you'll go down the abstraction layers, and more, you'll go further away from the real world. You'll find yourself in more esoteric places like memory management and hardware specific. Quantum mechanics is even beyond what we experience daily, but it's also a potential level of abstraction. So do the user of your software really care about technology it uses? Do he or she care about its architecture or its storage systems, or does he care about the transistor? Not really, not at all. So what's important for the customer is that the UI or user interface give him or her the power to solve the problems or answer he or she needs. Everything else is nicely abstracted and doesn't have to be of a worry for our end user. Now, if we go into the next area, utilization Uipath. How can abstraction be used in Uipath, and how can we gain a better understanding of it and reap the benefits in our automation journey and RPA projects? We have a client case, which is very good, and we can use it as an example of how to do development and how to kind of think about abstraction in your day-to-day business. So for example, here's a PDD, a classic PDD. In a normal kind of, what do we call it? In a normal classical automation process, you usually receive a PDD, or even you might develop a PDD with a client and follow the business requirements of a process. From there, there's a tendency that developers automate their processes based on the exact steps of the PDD. They have maybe not invested in how to make it optimal, how to make it less redundant, how to simplify it. So this is a very useful case of using abstraction, and I have a good example. So one of the client cases we have is that we have a very large Excel file, extremely large Excel file. It contains up to 100,000 rows of data with 30 different columns. The aim of the process is to validate these files based on another Excel files that contains lower bound threshold and an upper bound threshold, as you can see to the right of the slide. So from here, we can see that there are different criteria, different rows from -10 to -100, -5 to -25, and so forth. And they are different controls of this Excel file on different columns, which means that there are going to be different types of control. The general criteria that we do have here is that the row value should be either between the lower bound and upper bound, which are then non-critical, or we have that it should be bigger or equal to the upper bound than it's critical. So these are kind of the general requirement, but they have to be done on each of the controls and verified a different way. The classical automation way is that we do then an invoke for each of these controls. We do each control separately. We follow the PDD as is, which means that in turn, it comes to a lot of duplication, a lot of unnecessary work, a lot of redundancy. And if you have to change something somewhere in your code, which is kind of similar to your other controls, you have to do it on all other invokes as well. In this case, because there are, let's say, 9 different controls that are being made, it also means that there are, how many are there? Roughly 20 to 30 different data tables that are being produced as a result of it, and then has to be merged. It means also a lot of memory and will be taken up as well as a result of this, which can cause an issue on our clients' resources. So here we can see, I'm not sure if you can see in the slide, that there are control 1, 2, 3, and they kind of follow as we go along here. 1, 2, 3, 4, and it goes along. But if we go to our next slide here, let's see if this works. Okay, this didn't disappear. This is new. Take that away. Don't write here. So each of these invokes that is a control does kind of the same way. What it does is that it gets specific this criteria values based on which control it does. Is control 1 get row 1 of these upper and lower bounds, and then they kind of verify each of these data tables, same types of data tables that are being verified. So one loop, then there's another loop further down. But it means that they verify in the same way, and there's a lot of redundancy in each of these codes. In normal, I guess, RPA automation, it could be seen that this is how we should do it because it follows the PDD. But when you have to do maintenance or handover or support of this, it could be very tedious to quickly understand what it does, quickly jump into this, and also to correct the issues if they occur in many places. So how do we then use abstraction? Let's see. Yes. So instead of using in that way that we do each of the controls, we see that there's a lot of things that can be generalized, and we can use kind of one same invoke that validates all of this. So how this works now is that for each of these criteria that we pass through, first we kind of reset, of course, some loop variables that we have in here, but then we get the different criteria data for the different values, the lower bound, upper bound, and so forth. And then we also set control specific data. If the different controls that we do for this Excel file has specific data for them, we set them here. Maybe they have to filter the data table in a specific way based on the different criteria that they have. Then we do them all in here. And then, of course, they parse them as double later on, but that's something else. Then if we continue from there, this would be our generalization. We have one invoke that does the whole validation. It's not a very big invoke per se, but all it does is that it takes these values and checks itself which row it's doing, which means that which control is it doing. It's doing control 1, 2, or 3, and then validates that based on that logic. And the logic seems to be the same for all of them. So that's how it kind of works for the different data tables. And then from there, if there are any kind of specific validation that are outside the scope of these controls, let's say in our case, we had control 8 and 9, which are different from the other controls from previously, we put them as specific ones. So we try to generalize as much as we can, and then we try to specify specific validations for the other ones. So this is an example of how to use abstraction in Uipath. And generally what it means is you try to see where things are getting duplicated, where there's redundancy, you try to generalize it, and try to see how can we make it as nice and as tight as possible. All right, next step, good versus evil. So what are kind of the pros of abstraction? We kind of gone through this in some way, but generally there are some things. There are first compatibility, sorry. The hidden implementation can be made to work across browser, devices, platforms, whatever. There's also an ease of maintenance. The code is maintained in one place. There's also productivity, which means that it's quicker to use abstraction than reinvent its details each and every time. Also, of course, reuse of code. It aids the dry principles, which means don't repeat yourself, a very common principle in computer development. There's also the pros of refactoring. With implementation in one place, it's easy to improve the code generally. So instead of having multiple places of the same code, it's much more easy to improve it and optimize it in one and single place. You also have organizational clarity, which means that it's less visible code, is easier to read and follow. And of course, lastly, reduces errors, which is a big one. We code is in one place, errors aren't repeated across the whole project. But then, of course, there are some cons of abstraction. There is an additional learning curve to this. The abstractions needs to be learned by the developers, by everyone. It might take a bit of time to understand what this code does from the beginning, because it might be very complicated, very lack of details in some way. There's also a loss of knowledge about what's being abstracted in alignment to that. Learning the abstraction doesn't necessarily mean understanding the underlying language. Finding code, sometimes it's not easy to find where the implementation details are located, so it might be also hard to understand what this abstracted code does. But then also there's a con when it comes to fixing code. If you don't understand the underlying language, it could be difficult to correct the low-level errors. And that's also in regards to maintenance of the processes. Here's a very nice picture. It shows that how to abstracting, if it's too abstract or too realistic. You have to find something in between. All right, now we come into our last part, which are consequences of being mischievous. Let's see. And this is more, and we have a kind of a good statement here by Sandy Metz. He's a computer programmer and kind of a teacher in some way. And he says duplication is far cheaper than a wrong abstraction. And what he means by that is that if you abstract it incorrectly and do it wrong, it can be very hard to understand it, very hard to move a project forward. So maybe sometimes duplication might be easier. But in my general practice, let's just try to stay away as much from it. It is a very well-phrased principle. The wrong abstraction can and will become far more complex, hard to read or maintain than code duplication, as stated before. So everybody's intentions are good, of course. We're all just trying to write good code. At some point, you might recognize an unnecessary duplication, some components which share some functionality. You go ahead and do the right thing, extract the functionality, have them all lean and clean. Then a new requirement might show up. They always do. One of these components now has the teeny tiny change in its behavior, but still pretty much follows the standard. With one or small modification that will be added to the abstraction, everything is still good, right? And this kind of comes into this example we have now here, that we're seeing how wrong abstraction could be implemented in this code. This is, very simple code. It's some web development here. We can see some HTML. And it's regarding a very simple dialog component that can receive a title, a text, and a button. It's very lean, capable of receiving some data and present it. But let's say sometimes later, a few new requirements come. You need to handle types. As the dialog may be of type warning, success, danger, etc., you'd probably want to change this class accordingly so that the relevant style guide can kick in. No problem. We'll add a type prop, right? Also, you're maybe asked to handle a case in which there is no title and a case in which there is no body text. This leads into our second code here. This will add us a few conditions, but well, what can you do, right? When you get the requirements, you do what you're told. Some more time passes, let's say. Then comes another new requirement. We also need to handle a whole bunch of buttons instead of just one. So we'll now pass an array of buttons with their entire data and map through it. Still not a big thing to ask of this component. I mean, right? It should support such a trivial case. What if you also want to support an input, let's say? One could then use this dialog for a lot of other things like login, create account, for example. What about an array of inputs? It could be a long form of wizards or a wizard of sorts. I'm all for it, but let me say that inputs will also need validations. Let's say we pass the validation as another prop. Our dialogue is becoming more and more complex generally. Just one last thing for now. Let's say we want to also support a table format. Let's do it. Data might identify itself as a table. We're not here to judge. All right, so this is extreme and it's pure hell. We want a lean container of data, but we really had no control over what data is coming or in kind of what shape. Therefore, we ended up with tons of conditional paths. But the worst part is that the component doesn't know its purpose anymore. What's a dialogue really? Is everything a dialogue? You can see where this is going. As time passes, the abstraction is not really abstract anymore, but a huge bunch of different permutations depending on parameters and cases. After a few more iterations, the code is no longer readable. Let's say a year or two goes with this, the new employees in our team will not be able to understand what this abstraction actually does. Neither will you with time either. So things will break because we have put everything in one and single place as demand comes in. So kind of what is the point of this example I'm saying here? It's some remarks to, in case you do have this from a business demand or if something comes through, what to think about. So if you find yourself in this situation, take a step back, break the abstraction back into duplication, now observe it once again, which are the unique parameters of each component, leave them there, delete any logic that isn't particularly needed of this component. Now you can write a new abstraction based on only simple shared logic with no conditionals or side effects. If you find yourself adding conditional scenarios and passing parameters to an abstraction, you probably got the abstraction wrong. For an abstraction to work fantastically in a large number of contexts, it has to identify its precise use case. On one note, that can't always be the case. The more complexity the abstraction is trying to hide, the bigger the chance of it is to leak, which doesn't necessarily mean it is bad or useless, but we're talking about simpler cases here. Same goes when you think regarding naming an abstraction. A good abstraction has to declare exactly what it does. If you don't know how to name it, maybe you're not sure what it does, and that's not either a very good sign. And then lastly, we also want that we should write code that solves your current problem. That's kind of the takeaway from here. Don't attempt to get away with a perfect silver bullet abstract code that will be written once and prevent all of your future problems. If that were ever the case, none of us would have to work at all by now. The more common scenario is that your abstract joker will at some point, at some future point, be used as a 5-tone hammer on every problem. While we all try to lay a good foundation, it's really more like gardening than, say, building a house. Most of the decisions are reversible, and some will be revisited. And this is now the presentation that we had for this webinar. Thank you generally for listening. But wait, there's some more. We have some more polls and questions we would like to ask as an ending of this webinar. So I'll try to launch this webinar. Not webinar, I'll try to launch this polling. All right. So we can see that most people are here in this webinar understood what the concept of abstraction and hopefully learned some from this webinar. We have one that was, or two that was 7% sure, and fair enough. You can always read this on your own as well. But it is a very useful concept and a very fundamental concept that's getting very misunderstood sometimes, and something that we've seen kind of lacking in a lot of our clients, in a lot of other developers or other consulting companies that do, let's say, RPE project there, and even people who do coding in all the coding in the main method, for instance. It is very common that this happens, and it's a very useful concept to learn and understand. So I'm very happy that you feel that you understood the concept of abstraction. We also have another last question. Let's see if that works. Yeah, we also have another question. Now it came up. All right, great. Now you can also see the results. Seems that a lot of you understood how to practically apply abstraction, which is great. You understood the concept, some of you, but not really how to apply it, which is also fair enough. I could have gone more in depth how to really apply it. I tried to more discuss how it can be used. But I'm happy that there was at least no one that had not really there was no one who did not understand abstraction or how to practically apply it. So that's great. And then I think we also have a last question, if I'm saying this correctly. Let's see. Can I do this? Yeah, we have a last question about future webinars from Akua and what we would like us to focus on. There are some areas that we have a suggestion, and we're also, of course, willing to take in other suggestions. One of them is machine learning. One is also how to work with big data. One is also maybe regarding security and cryptography, how we can maybe work in parallel with that. All right, I'll share the results. And here we can see that most people were interested in learning about machine learning, and some were interested in learning about RPA and big data. So this is very good insights, and thank you for sharing this. We'll hopefully have future webinars in these areas as well. So outside of the polls and questions, we also have our last slide, which is let's see if I can get to it. There we go. So here we have a QR code which you can use to access our site and come to where to contact us. If you want to contact me directly, here is my email. And if you want to do any form of collaborations or partnerships or whatnot, please contact us and we'll have some good discussions and dialogues from there. Thank you all for coming to this webinar and listening to me. And I hope you guys have a very good rest of your day. I'm going to see if there are anything in our chats for questions. We don't seem to have any questions right now. If you have any questions, you can always email me as an alternative if you don't want to write in here. Otherwise, have a great day, everyone, and thank you for listening.